program on recent advances in mathematics and statistics. So let us begin this FDP inaugural by inviting our dignitaries. With immense honor and respect, we welcome the Chief Patron of this FDP, Shri M. Sri Bharat Garu, President, GITAM. Welcome, sir. With great privilege and respect, we now welcome the patron of this FDP, Professor Shri K. Sivaramakrishna Garu, Vice Chancellor, GITAM. Welcome, sir. With immense pleasure and respect, we welcome the co-patrons of this FDP, Professor Shri A. Subramanian Garu, Dean Science, Professor Shri M. Saraschandra Babu Garu, Principal of GIS, and Professor Shri S.S. Prasadarao Garu, Director, Center for Learning and Sustainability, GITAM. Welcome, sir. We take a great delight in welcoming the chairman of this FDP, Professor N. Ravishankar Garu, Professor and Head, Department of Mathematics, JAS, GITAM. Welcome, sir. We extend a warm welcome to co-chairman of this FDP, Professor Shri A. Chandrasekhar Garu, Department of Mathematics, GIS. It is an honor and privilege to welcome the resource persons of this FDP, Professor Shri Jammalamadaka Srinivasa Rao Garu, Distinguished Professor, Department of Statistics and Applied Probability, University of California. Professor Shri Shashikant Mishra Garu, Professor, Department of Mathematics, Institute of Science, Benares Hindu University. Professor Shri V. Kannan Garu, Professor and Head, Department of Mathematics, SRM University. Professor Shri K.R.R. Gandhi, Professor, Department of IT and Operations, Institute of Management, GITAM. Professor Shri K. Srinivasa Rao Garu, Principal, Science and Technology, Andhra University. Professor Shri Yadavalli V.S. Sharma Garu, Professor and Head, Department of Industrial and System Engineering, University of Pretoria, South Africa. I extend a warm welcome to Shri Umashankar Garu, Rayalaseema University. Welcome, sir. I also welcome distinguished professors, advisory board members, organizing committee, research scholars, and industrial persons for this inaugural function. Let us start this section with a prayer.
दुर्बुद्धि विनाशाय दीपज्योतिर्नमोस्तुते दीपज्योतिर्नमोस्तुते शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः शुभं कुरु त्वं कल्याणम् आरोग्यं धनसम्पदः.
Kameshri ma'am.
Thank you, everyone. Now I invite Dr. Sridhar, Associate Professor, Department of Mathematics, to put forward briefing about department and FDP.
Thank you, madam. Respected dignitaries in the panel, my dear colleagues and participants. Very good evening. This is Dr. Sridhar Namburi from Department of Mathematics. I am sharing the brief introduction of the from the Department of Mathematics. So the Department of Mathematics at the Institute of Science, GITAM, deemed to be university. Initially, the Department of Engineering Mathematics was established in the year 1980 under the College of Engineering, GITAM. Since its inception, the department has been functioning with the prime object of developing a hub of excellence in mathematical sciences and its applications, and also catering to the needs of engineering students. However, in compliance with the vision and mission, the Department of Applied Mathematics was started in the year 2003 and was functional under College of Science, GITAM. On 17th July 2019, the Department of Engineering Mathematics was merged with the Department of Applied Mathematics and renamed as Department of Mathematics. At present, the Department of Mathematics has 32 well-qualified faculty members and are actively involved in research and guiding students in pursuing a career in mathematics. The department aims to provide high quality of mathematical training for future professional mathematicians, engineers, business professionals who undertake research which will have an impact on the society. We are offering two undergraduate programs, BS in Mathematics, Statistics, Computer Science, and BS in Mathematics, Statistics, Data Science, and two postgraduate programs, BS in Applied Mathematics and MS in Statistics. The department also offers MPhil and PhD programs in Applied Mathematics. Apart from this, the department renders its services to Institute of Technology, School of Architecture, Institute of Pharmacy, and all life science programs. The faculty are involved in active research in the areas of boundary value problems, complex analysis, cryptography, fluid dynamics, fuzzy set theory, group theory, operations research, relativity and cosmology, reliability theory, supply chain management. Moreover, we published more than 700 research papers in various reputed national and international, and also guided more than 30 students for their doctoral degrees. The department has to travel over a long distance in a globe. For that, the curriculum is designed and often revised depending on the developmental requirements of industry and other stakeholders. Offering new programs from time to time and organizing the activities like seminars, conferences, workshops. In view of this, the Department of Mathematics has planned to organize the online international faculty development program on recent advances in mathematics and statistics in connection with the birth century of Professor C.R. Rao Garu, with renowned and world famous speakers. Within a short period of time, more than 3,000 registrations have come up from various parts of India and abroad. Definitely, this is a wonderful platform for the faculty members of mathematics and statistics to exchange their ideas with each other on the latest emerging trends in the field. Now coming to the program is scheduled for 6 days from 3rd August to 8th August. Today, Dr. Rao Jammalamadaka garu, Distinguished Professor of Statistics and Applied Probability, University of California, USA, will deliver a talk on the topic A Matter of Direction. Tomorrow, that is on 4th August from 4 p.m. to 5 p.m., Dr. Sashikant Mishra garu, Professor of Mathematics, Banaras Hindu University, India, will deliver a talk on unconstrained optimization problems. Day after tomorrow, that is on 5th, we are organizing two sessions. The first session starts from 4 p.m. by Dr. V. Kannan garu, Professor and Head, Department of Mathematics, SRM University, and former Pro Vice Chancellor of Central University of Hyderabad, India, will deliver a talk on sequences of real numbers. And followed by Dr. K. R. Gandhi garu, Professor of IT and Operations, GITAM deemed to be University, India, will deliver a talk on relevance of data science in mathematics. The next day, on 6th August, Dr. K. Rao garu, Senior Professor of Statistics and Principal, College of Science and Technology, Andhra University, India, will deliver a talk on regression analysis and its limitations in data analysis from 4 to 5 p.m. On 7th August, Dr. V.S. Garu, Professor and Head, Department of Industrial and Systems Engineering, University of Pretoria, South Africa, will deliver a talk on applications of point processes in reliability theory from 4 to 5 p.m. The last day, on 8th August, Dr. P.V. Arunachalam Garu, former professor of mathematics, Sri Venkateswara University, and former vice chancellor of Dravidian University, India, will deliver a talk on some breaking throughs in mathematics from 4 to 5 p.m. So this is the brief schedule of the program. I hope that all of you would have a great learning experience. Thank you one and all for giving me this opportunity.
Thank you, Sridhar garu, for giving the insights into this. Now, I invite Dr. V. Sirisha, Associate Professor, Department of Mathematics, GITAM, to say a few words about Professor C.R. Rao garu.
Thank you, Madam. I deem it a great privilege to be able to brief about Professor Kalyampudi Radhakrishna Rao, known as Professor C.R. Rao, an Indian-American mathematician and statistician. He earned MSc in Mathematics from Andhra University and MA in Statistics from Calcutta University. He obtained PhD degree at King's College in Cambridge University under R.A. Fisher, the father of modern statistics, in 1948. A few years later, in 1965, the university awarded him the prestigious Doctor of Science degree based on a peer review of his research contributions to statistics. Professor C.R. Rao worked in India at the Indian Statistical Institute for 40 years before he took mandatory retirement at the age of 60. He moved to USA and worked for another 25 years at the University of Pittsburgh and the Pennsylvania State University. He received 31 honorary doctoral degrees from universities in 18 countries spanning 6 continents. Professor C.R. Rao is the author of 475 research papers published in prestigious journals and 11 books. One of his books, Statistics and Truth, was translated into various languages, and another book, Linear Statistical Inference, used as a textbook, has been in the market for over 50 years. He has edited 39 volumes of Handbook of Statistics dealing with the latest methodologies in statistics. As head and later director of the Research and Training School at the Indian Statistical Institute for a period of over 40 years, Professor C.R. Rao developed research and training programs and produced several leaders in the field of statistics. On the basis of his recommendation, the Asian Statistical Institute, now known as Statistical Institute for Asia and Pacific, was established in Tokyo to provide training to statisticians working in government and industrial organizations. Among his best-known discoveries are the Kramer-Rao bound and Rao-Blackwell theorem, both related to the quality of estimators. Other areas he worked in include multivariate analysis, estimation theory, and differential geometry. His other contributions include the Fisher-Rao theorem, Rao distance, and orthogonal arrays. For his pioneering contributions to statistical theory and applications, Professor C.R. Rao received numerous awards. He has been elected to the National Academy of Sciences, USA, American Academy of Arts and Science, Fellowship of Royal Society, Indian National Science Academy, and many more. He has been the president of all prestigious statistical associations, namely the International Statistical Institute, Institute of Mathematical Statistics USA, and the International Biometrics Society. Professor C.R. Rao was honored by the President of USA with the prestigious National Medal of Science as a prophet of new age, with the citation for his contribution to the foundation of statistical theory and multivariate statistical methodology and their applications, enriching the physical, biological, mathematical, economic, and engineering sciences. He received the Bhatnagar Award of the Council of Scientific and Industrial Research, in short CSIR, India. He donated the entire prize money to the Prime Minister's Defense Fund, saying that country's need is greater than that of an individual scientist in fighting unprovoked aggression. The government of India honored him with the second highest civilian award, Padma Vibhushan, for outstanding contributions to science and engineering and statistics, and also instituted a cash award in honor of Professor C.R. Rao, to be given once in 2 years to a young statistician for work done during the preceding 3 years in any field of statistics. One of his notable students is Professor Rao Jammalamadaka, today's invited speaker of this program. As the paucity of time, I could be able to quote only few achievements of CR sir. Thank you one and all.
Thank you, Siresha garu, for giving us the achievements of Professor C.R. Rao garu. Now, I consider a great honor to welcome Director, Center for Learning and Sustainability, Professor Sri S.S. Prasad Rao garu, to share his views. Over to Prasad Rao garu.
Yeah, thank you, Kamesri Madam. Honorable President, Sri M. Sri Bharat Garu, Honorable Vice Chancellor, Sivaram Krishna Garu, the Dean Sciences, Subramaniam Garu, the Principal, Institute of Science, Professor Sharat Chandra Babu Garu, and the Head of the Department, Chairpersons, Conveners of this program, the International FDP, and more importantly, the resource persons of the day and the coming days. A very warm welcome to all of you. It's a great privilege for the Center for Learning and Sustainability to join this kind of program while inviting a very, very well-known resource persons across the world, making a very good stride in this field. GITAM is always ahead of many institutions doing this kind of activities. The GITAM is not only a teaching and research organization, it is the most learning and most happening place in the world today. We all are grateful to the management for extending support every time whenever we reach to them in a very, very liberal way. We are all grateful to them. And this kind of program is not very easy to coordinate unless there is support from all the top management. We are getting wonderful support. Friends, these maybe 6-day program, but there are 7 eminent resource persons as has been introduced by one of the conveners of the program. I'm sure there is great learnings going to happen today and all the remaining days also. And most importantly, the team who are the team comprising the conveners and chairpersons of the program are all working to facilitate all the participants and also resource persons any kind of support required from time to time. I'm sure these days are going to enrich our knowledge and wisdom with the thoughts and insights of the wonderful resource persons. Thank you one and all for giving the Center for Learning and Sustainability an opportunity to do this kind of programs. Thank you very much. Over to you, Sirisha Garu.
Thank you very much, sir, for allotting your precious time and sharing your valuable perceptions. Now, I am delighted to welcome Honorable Dean Science, GITAM, Professor Sri A. Subramaniam Garu, to share his valuable insights. Over to Subramaniam.
Thank you, Ms. Kameshwari Garu. Dear invited speakers, participants, and dignitaries, a very warm welcome on behalf of GITAM. You already know more about Professor C.R. Rao than me. I had a very small interaction of his work on multivariate analysis. What I really understand is mathematics is the language of science and engineering, which is the backbone, and statistics is the pathway for the future. And I'm pretty sure this international faculty development program is going to bring more and more knowledge for all the participants, giving a way for what we are supposed to do in the future. And what we have to learn from the entire faculty development program is not only the topic and its topicality and the depth of it, but also we should see how these resource persons have achieved such great heights. And Professor C.R. Rao happens to be a beacon of all the mathematicians, statisticians all over the world. And we must emulate what how we should have this excellence. I congratulate my colleagues in the mathematics department of the GITAM and the Center for Learning and Sustainability of GITAM. And this is a very thoughtful conduct of this faculty development program, and that too opening this up for the international community. You may wonder what it is. The wonder is we at GITAM work with commitment and empathy. These are the two most important points. More is going to come from our President Sri Bharat Garu, and the present faculty development program is just one example. Let me not take more time. And I must really thank all the organizers for giving me this opportunity to say hello to you. And I'm saying this hello all the way to Santa Barbara, Professor Rao Garu, and all my colleagues in India. We should now thank COVID, because COVID brought all of us together. So let us work better, work towards excellence and commitment. With this, I would like to say thank you very much. Back to Kameshwari Garu. Thank you.
Thank you, sir, for granting your precious time in spite of your hectic schedules and sharing a valuable information. Now, I request Honorable Vice Chancellor, Professor Sri K. Sivaramakrishna Garu, to kindly share his conceptions. Over to Sivaramakrishna Garu.
I'm not sure he's here, Andrew.
Yeah, I think he's not yet here. I think maybe Kameshwari Garu.
Yes, sir, he is there, my friend. He is there.
He's there?
VC Garu joined, sir. VC Garu, just I called. Sir is saying that he is joined.
Okay, problem. Okay.
Otherwise, President Garu.
Sir, I don't see him here in the audience. Is Shiran Krishna Garu, if you are here, please share your message.
No, I don't think he's there. We should move on to the President's address.
Sure. Should I get started?
I think
Now, I request our Honorable President, Sri M. Sri Bharat Garu, to kindly share his message.
Sure, and I'm happy to share my message, but can you let me know who my audience is? Is the audience maths faculty from across the country? Is that correct?
Yes, sir.
Yes, sir.
Okay. And the topic is developments in maths and statistics for this
Yes, sir.
Okay. Good evening, everyone. Welcome to all of the guests, both national and international, and to faculty members who are participating. Thank you for giving your valuable time to this. So there are two things that I'd like to speak about today. I won't take too much time. One is about the subject itself, and the other is the environment or the current times that we are living in. So in terms of developments in maths and statistics, I'm by no means distinguished enough to talk about that, because I'm not a mathematician or a statistician. I'm an engineer by undergraduate education, and I've done an MBA after that. But I've been a very avid maths student. I loved math as a young student, and I did really well in school and in college, and that's always been my strongest subject. And the engineering that I did in industrial engineering was a very math-heavy engineering. Almost every course that I did incorporated mathematics in it. Now, in terms of developments, let me speak from the user perspective. I'm someone who's consuming your mathematics that you're either teaching me or you are furthering the knowledge in mathematics. In either of those domains, as a student, if I cannot understand what is being taught to me, or if I'm not motivated by what is being taught to me, then the whole purpose of knowledge itself is defeated. And I would, if anything, I would ask all faculty members to spend their energy, in particular because of the particular time that we are in, COVID. some of my observations in the last 15 minutes itself, I think a lot of our etiquette in a physical environment does not necessarily apply to an online environment. And that is the transition that all faculty members have to do, in particular in this 1 year where we are experiencing COVID lockdowns around the world. But more so in the future, I think this is not a temporary change in our world. I think some of these changes will become permanent. I think international speakers earlier used to participate largely only physically, but now we have Prof. Jammalamadaka coming from California and from probably the comfort of his office or his house participating with us here. And this makes it so much more easier for us to bring in experts from around the world, collaborate, and further knowledge and research. So given that the impact of COVID is here to stay, and that we do have to adapt to online learning, what does that mean? It means that the challenges that we were earlier facing in the physical environment about teaching mathematics in particular was multifold. If you're in a classroom of 60 students, there are some students who understand math very well and some who don't understand it as well. But as a teacher with 60 minutes in a section, you may find it challenging to teach all students well, because you cannot personalize to each individual. But today with online, any lectures can be recorded. Any student can view your lecture at home and they can learn. But the challenges of online are, unlike a physical classroom, I've been your student here listening to you faculty members speaking and introducing. It's very easy to lose attention in the online format. And now it's no longer about knowledge dissemination. I think it is about engaging the audience and participating, making them participate in the learning process. So in spite of me not being able to see the attendees and the participants, for me, it is critical that we can communicate with each other. And I think the features of Zoom, like the chat, I see a lot of people are commenting on the chat and the Q&A. These are the things that need to come into the way we communicate. Because I was earlier in a conference with a professor from Harvard, and they were speaking, and they broke down learning into 3 aspects. I can't remember all of the phrases, but one was basically the intellectual learning, one was the social learning, and I think the other one was peer learning. So one part of that learning is we can clearly do it in the online format. We have knowledge, we can pass it on to our audience, and I'm sure you will do that over the next 6 days. But how are you going to engage them, and how are they going to learn from each other? These are the 2 questions that are important. Because we may be the most knowledgeable people in the world, but when we are speaking, if the other person doesn't understand what we're saying, it amounts to not much. And I think that is the challenge that many of you maths faculty will be facing, in particular in the year ahead and in the future as well. And the other, as a nation, we're 70 years old, and as a university, GITAM is 13 years old. Relative to the US, I think we have universities that are far younger, and research as an ecosystem hasn't picked up in our country like it has in others. If you were to look at the sheer volume of research and the qualitative aspects of research, I would say that India is probably not even in the top 10 countries today. But as a nation, if we are to progress, mathematics is one of the core fundamentals that we require to do well at. And the research that many of you are doing should not be just, what should I say, relegated to research journals that not many people read. It's how do you translate your research to real life impact, and how do you collaborate with others across the field? Because today technology is getting into everything and mathematics is getting into everything. How do mathematicians collaborate with doctors? How do statisticians collaborate with doctors, particularly in COVID, to look at what are the trends, what can we see? So if I were to say what are the developments and updates, the days of operating in silos are no longer going to help us much in the future. as a faculty member in your own discipline, I think it's critical that you collaborate with people across the board, not only in the basic sciences, but in every other discipline that you can think of. And that is the ask. And if you would like to contribute to your students as teachers, I would love to hear examples of my maths teacher linking a real world problem with a mathematics theory. That is something that I haven't seen as much in university curriculum in the country. So the more and more we can do that, I think the more participative learning becomes. In terms of our organization, a little bit of inputs. I mean, like everyone else, we had to go into lockdown in March, and the last 4 months we've been working virtually. We've partnered with Coursera, an online learning platform. And through that platform, we offered licenses to all our faculty members and students. And we've encouraged all our faculty members to pursue any course of their interest, and in particular in their area of discipline or research, so that they can learn from the best universities across the world, what kind of research is happening there, what kind of teaching is happening over there, and how can we bring those practices to GITAM and to India. And so far, the response has been fantastic. About 126 faculty members and students have done a minimum of 10 courses. And amongst the 126 people, they have consumed about 2,300 courses in the Coursera platform in the last 3 months. I'm very happy to see that appetite for learning. I think we need to constantly keep learning and keep ourselves abreast with developments not only in our field, but in other parts of the country. And there's 6 more days left here. I hope that GITAM is able to provide value to all of the participants, and they walk away feeling that they have learned something that is going to help them in their own areas, whether it be mathematics or statistics. And I also welcome all our guests who have kindly agreed to give us their time and to share their experiences with our faculty and also participants from across the country. Thank you.
Thank you, sir. Thank you very much, sir, for gracing us with your presence and taking out valuable time of your very busy schedule. We are all inspired by your great words, and I am sure, sir, this platform will reflect the goals and visions set forth. Thanks again, sir. Now, I invite Dr. V. Sirisha to introduce today's resource person, Shri Srinivasa Rao Jammalamadaka. Over to Sirisha.
Thank you, madam. I deem it a great privilege to be able to introduce Professor Srinivasa Rao Jammalamadaka. Professor Jammalamadaka is among the leading researchers in statistical science during the last 5 decades. Author of 3 books and close to 200 publications, his research, scholarship, and professional services have had a great influence on the theory and applications of statistics. Professor Jammalamadaka earned his Master and Bachelor of Statistics from the Indian Statistical Institute, Kolkata, India. From the same institute, he obtained his doctorate under the supervision of Professor C.R. Rao Garu. He started his academic career at Indiana University before joining University of California, Santa Barbara in 1976, where he is now a distinguished professor. Professor Jammalamadaka achieved international reputation for pioneering work in developing new tools to analyze nonlinear phenomena like directions and circularity. He has held visiting positions in various universities, including University of Wisconsin, University of Leeds, Uppsala University of Sweden, Indian Statistical Institute, Kolkata, Indian Institute of Technology, Bombay, Chalmers Institute of Technology, and Göteborg University, University of Malaya, and the Australian National University. He is the founder of the Department of Statistics and Applied Probability at the University of California, Santa Barbara, and led the department from 1989 to 1993. For his pioneering contributions to statistical theory and applications, Professor Jammalamadaka received various awards and medals. He has been an elected fellow of the American Statistical Association, the Institute of Mathematical Statistics, the Institute of Combinatorics and its Applications, the CYO Corner Fellow of the Curtin University of Technology, Perth, and an elected member of the International Statistical Institute. He has been awarded an honorary doctorate by the Swedish University of Agricultural Sciences in 2014 and honored with Outstanding Graduate Mentor Award by the University of California in 2017 in partial recognition of the fact that he supervised 45 PhD students so far, who are now working as academicians and as statistical practitioners in various organizations all over the world. He has been an invited speaker at more than 300 national and international statistical meetings all over the world on topics including problems of weak convergence, directional data, and non-parametric statistics. He has been a member of the editorial boards of Statistics and Probability Letters, Stochastic Modeling and Applications, Journal of Non-Parametric Statistics, and the Journal of American Statistical Association. GITAM is privileged to honor Professor Rao Jammalamadaka garu, a renowned scientist, an inspiring teacher, an able researcher, a profound statistician, and a great humanist on this occasion. Thank you, one and all.
Thank you, Madam, for sharing the achievements of our distinguished Professor Sri Rao Jammalamadaka. Now, I request Professor Sri Rao Jammalamadaka to kindly share his message. Over to Jammalamadaka.
Thank you, Sirisha, for that wonderful introduction. I think, I'm reminded of my visit to GITAM in 2005 when I was helping with a workshop on data mining. This was way back in 2005, and I'm happy to be back again, if not physically, as part of this faculty development program. It's a wonderful idea, this program of refreshing faculty in terms of new ideas, novel things that are going on in different aspects. And this might inspire some of these participants into thinking about these ideas and maybe developing some of them and developing new areas of research. So I'm very, very happy to know that there is such a faculty development program and that GITAM is actively taking active part in this. And I like to thank the various organizations that have been conducting this, the Department of Mathematics and the Institute of Science and the Center for Learning. And I think it's a great idea. I'm very happy to be part of this. And I really like to thank GITAM for inviting me to share my ideas today. Thank you. Thank you, Kameshwari.
We wholeheartedly thank our distinguished speaker of this session for sharing his valuable views. We might likewise want to offer special and sincere thanks to all GITAM management for their support and providing a platform for conducting this event. We are also thankful to all the participants for attending this inaugural session and looking forward for active involvement in coming sessions. With due respect, I now invite Professor S.R. Jammalamadaka to deliver his talk.
I'm going to start showing some slides and give a talk based on this. I hope you guys can see my screen at this point. Do you get to see my screen?
Not yet, sir. Not yet. Now, yeah, I think now we can see it.
Okay, let me see where my screen is in the first place. Okay, now you can see the screen, right?
Yes, we can.
Okay, I'd like to make it a bit bigger. Let's see if I can do that so that we have a full screen doing the job for us. Okay.
Right now, it's a blank white screen, sir. Is it different on your front?
I'm I have a screen that has the slides, first slide.
No, I don't see any slides. I just see a blank white screen. I do see your screen, but it's blank white. I can't see any
Okay, let me see what I need to do for that. Well, this is the first time I'm trying to give a talk on webinar, so
no, that's fine. I think we've all had our learning curve on this online.
let's see. Let me start over again in this. This is the white screen.
Stop share and then share again. Maybe it may come through this time.
Okay. Share. Let's see. I'll say share screen. Okay, and then I click my whiteboard. Is how about it now? Do you get to see my screen at this point or no?
Showed up yet, sir.
Share it again, sir.
Yeah, it's begun. I still only see your whiteboard and I see a pointer.
Okay, no, that is what I'm seeing, but that is not. Oh, come on, this is not going to.
Can you close the whiteboard and probably, I think at the time that you're sharing the screen, you're clicking on the whiteboard instead of clicking on the PowerPoint presentation.
Okay. I think you're right.
Yeah.
How about it now?
Yeah, now we can see your presentation.
Okay, boy, you taught me something already. Okay. Yeah. I have not given these lectures yet. I'm going to start giving these online lectures as of October. Any case, okay, this is I'll make it a full screen now, and hopefully this will make it even bigger for those of you who want to see it in full screen. Okay, are we still on it, the screen?
Now it's a full screen, so I can see the full screen.
Okay, wonderful. Thank you. Okay, now my talk, I titled it tantalizingly, I call it a matter of direction. A matter of direction. Direction is the measurement that I'm interested in, directions of various kinds, and I'll tell you where such directions come in and how statistics plays an important role in various disciplines in solving scientific problems. So I'm going to start with, and incidentally, this is somewhat similar to a talk I gave in the Indian Science Academy in Bangalore in November sometime, but it's about the kind of questions, scientific questions. I ask questions of various kinds, and then I tell you how the directional measurements and come into play, and tell you why they are different from what we generally teach in our statistics courses, where we teach a normal distribution, the mean, variance, things like that. I'll tell you that there is these kind of measures and models are not appropriate for this particular area, and I'll tell you what else can we do. And then I go back to the scientific questions and how they relate to directions. And then I'll talk a little bit about what's called a random walk problem and testing isotropy. Isotropy about whether directions are uniformly distributed. And then this last bit is a bit of not very proper for an Indian audience, but nevertheless, we'll see. My name starts with Rao Jammalamadaka, and the question is, I'll tell you how I changed from J.S. Rao to Rao Jammalamadaka. As someone pointed it to me, this has something to do with directional data. Anyways, we'll see. Okay, so here are some scientific questions. Did a river change its course or geological time? This is exactly how I got started in this field of directional data. Or maybe I should preface all this by saying, I was in the first batch of bachelor's in statistics degree at the Indian Statistical Institute, they call BStat, and C.R. Rao was my class teacher. Class teacher is someone whom you see every day, and then he was for 4 years my class teacher. Then he was my master's degree and PhD advisor. And the PhD topic came about in the following way. There was this usual thirst for pure mathematical theories and I was trying to look at Kramer-Rao bound and functional spaces and topics like that. Very mathematical, esoteric topics. And then one day, Dr. C.R. Rao sends me a geologist. His name is Supriya Sengupta. He's quite well known. And he comes to me saying that they have been studying this Godavari River Valley in Adilabad district. And this river doesn't exist anymore, but at one time the river used to flow in that region. And he had data on the flow of the river, direction of flow of river. This is called paleo currents, currents of the past. River was flowing in a certain direction at one time, and he says at a different time point, the river was flowing in a different set of directions. He collected a set of directions of the river flow at time 1 and at time 2, considerably different time. And then he wanted to know, did the river change its course? Or geological time, I mean, million years later or such. That's one of the questions. Okay, scientific questions is what all I'm going to tell you, and then I'll explain to you where directions come in. Okay, is the ozone level in Santa Barbara affected by the pollution levels in a major city nearby? We live near Los Angeles, which is a pretty large metropolis, and there's a lot of activity and pollution there. And the question is the ozone level, for example, one of the pollutants, is it affected by pollution levels in a major city nearby? Migration patterns of animals, as for instance, monarch butterflies in Santa Barbara. I give you a picture of monarch butterfly here. These are very, very pretty butterflies that pass through Santa Barbara once every year. They come in from some direction and they fly back in a different direction. Thousands and thousands on them. These are so pretty that apparently they make ornaments out of the wings of these butterflies. In any case, these are called monarch butterflies, and these are migration patterns. One of the biology professors approached me and said, we'd like to study the direction of flight of these butterflies. Where are they coming from? Which direction are they going? Is there scientific evidence to support the hypothesis of continental drift? Completely different topics, okay? Is the Earth's magnetic pole reversal a fact or a fiction? Magnetic pole, north-south pole of the Earth reverses itself. North becomes south, south becomes north. Some of you must have gathered it's happening right now, apparently. And if true, how frequently does this happen? All this, is there a pattern to the epicenters of earthquakes? Is the globe, and the earthquakes occur at different time places, and is there a pattern to these earthquakes? Is there justification to the sociological theory that more people die after a major event in one's life than before the event? This is something very interesting. People say, for example, if a Christmas is coming, more people wait to die in the sense 2 months before Christmas. If you look at how many people die and look at how many people die proportionately 2 months after the Christmas, or your own birthday, for example, less people die 2 months before their birthday than 2 months after their birthday, apparently. So this has been a lot of studies on this topic. And is there in fact, we are all familiar with this story where in Hindi movies, there is this, ill mother on the bed waiting for his son to come back from Canada or USA or someplace. And she waits until he comes back and then she passes away. So apparently human beings have an ability to postpone death or control the event in some fashion. In any case, the question is there empirical evidence to support some such? If a woman has to undergo certain surgery, what part of her menstrual cycle is the better time? That's an interesting question about surgeries and menstrual cycles. And is there a particular part of the day when more heart attacks occur? See, this is the 24-hour cycle here, 0 to 24, and the x-axis. And then this is the proportion of people who died. This is a paper that I copied this data from. These are the 4 months, 4 seasons. And then in each of these seasons, you see there's a prevalence of deaths around the 10 a.m. in the morning, 11 a.m. in the morning. That's when people are going to work, apparently. So maybe that's the connection. But is there a particular part of the day when more heart attacks occur? Is a company cheating on its taxes? Very different questions. Is a student copying an essay from another source? How far do mosquitoes travel from their breeding ground, say a pool of water? This is a very important question. You know, there's a pool of water, mosquitoes seem buzzing off in different directions. How far will they be from their breeding ground? That is one of the questions I'll try to tell you something about. And then recently, I have been working with someone at the University of Pittsburgh, and he is working on the study of glaucoma. Glaucoma is a very common disease as people age. What the ophthalmologists do is they measure the so-called intraocular pressure in the eye. And they say if it's more than 20 or somewhere around that number, they say you have glaucoma and they give you eye drops or they do some operations. And then we recently are looking at what are called sophisticated measurements on so-called optical coherence tomography and measurements on the thickness of neuroretinal rim and the retinal neurofiber layer around the eyeball. These are sort of measurements around the retina. And then, I think your dean was mentioning to me about retinal problem for infants. And I think this is an interesting question. We are trying to see, can we use these circular curves as predictors of glaucoma? That is the question. So this is, so a common theme to all these questions is that the empirical statistical evidence comes in the form of data, which is a set of directions. Hence the title of my talk, A Matter of Direction. In many physical and natural sciences, I mentioned already some examples, geology, biology, ecology, basic measurements are quite often directions, not linear measurements, not on the real line, not like heights and weights. This is what C.R. Rao's book is called Linear Statistical Inference. It's about measurements on the real line, measurements on Euclidean spaces, multivariate, but they're nevertheless what we call linear measurements, linear inference. That's how the C.R. Rao named his book. And this, on the other hand, these directions are quite different creatures. They are, in practice, these directions are in 2 dimensions or in 3 dimensions, but could be in higher dimensions as some of the questions I raised. So directions can be measured in 2-dimensional directions, like which way is the wind blowing, or things like this. I mentioned already examples, so I'll come back to tell you a bit more. A direction in 2 dimensions can be represented as a point on the circumference of a circle, whose radius can be taken to be 1. You see, the magnitude is not important for the vector, for the angle, for direction. So I think of it as a point on the circumference of a circle. Each point on the circumference of a unit circle will tell me a given direction, okay? Or as an angle on 0 to 360. And such a set of observations are called circular data. What are circular data? They are points on the circumference of circle, numbers around the circumference of a circle. And we're all familiar with statements like the wind is blowing in a northeasterly direction. But if one wants to be precise, we can assign a number from 0 to 360. Here is how a direction in 2 dimensions might be thought of. It's like an angle theta, 0 to 360, or it's like a point on the circumference. Right there, that point represents a direction on the circumference. Now, you see this theta I already wrote in terms of cosine theta and the sine theta, the 2 components as a, this is what you might call, I'll perhaps say that in the next slide, but nevertheless, while you are at this place, you can see this 1 is the length of the vector and theta is the direction. So these are the polar coordinates. And cos theta, sine theta are the rectangular coordinates. So you can write in different ways this particular direction as a point on the circumference, as an angle, maybe as a vector, cos theta, sine theta. Similarly, a three-dimensional direction can be represented by two angles, longitude and latitude. I won't labor that point, but you can see on the Earth, you can take two angles and you know what longitude and latitude is. For example, Visakhapatnam has its own longitude and latitude that tell you where you are located on the surface of a sphere. And I labor that point, but maybe we should skip that. A three-dimensional directions has two angles, this phi and theta. They go in minus pi to pi and minus pi over 2 to pi over 2. Longitude goes west to east, north to south. And these can also be represented as three-component rectangular coordinates, x, y, z. So there is a vectorial representation. And if you have points on the circumference of the surface of the sphere, we call them spherical data naturally. Okay, so the points can be on the circumference of circle, 2 dimensions, or on the surface of a sphere, or maybe in higher dimensions, it could be in a much higher dimensional spheres. Any case, for observations on the real line or multivariate data, there's a natural zero and an ordering. When we say the weight of a particular object is zero, we know it doesn't exist. It's a natural zero is there. Zero and ordering. We know someone is taller than another guy. So there's an ordering in terms of heights and weights and so on. But in dealing with points on circumference, both the starting point and the way in which we order things are both arbitrary. In linear statistics, typically one uses this familiar sample mean x bar and the variance s square as measures of location and variation, as well as other measures of assessing other properties, measures for assessing other properties. However, the standard measures are of no use when dealing with circular data. So, okay, the point I want to make is directional data have no natural zero. There's no zero direction. I'll tell you, as I speak to geologists, they tell me true north is where the zero is. They call it an azimuth. And if you talk to a mathematician, they tell you true east is the zero direction, right? So both are right. But on the other hand, you get different numbers depending on where you put your zero. And in linear statistics, this is important to notice. Linear, I used with capitals here to say, these are measures of location, and then you build a lot of theory behind it. Sample mean comes from a normal distribution. How does X bar behave? How does the sample variance behave? How do we do tests of hypothesis? Everything we do in univariate as well as multivariate statistics and linear statistics, this sample mean, sample variance play an important role, besides other measures, of course. Such standard measures are no use with dealing with circular data. So we are cutting down right at the bottom. We are saying those linear measures are no good. For example, if you have a point here, is this 60 degrees or is this 30 degrees? You ask a mathematician, he goes this way and says it's 60 degrees. And the geologist says it's 30 degrees coming, clockwise. So the sense of rotation as well as the choice of origin is arbitrary. So the numbers you assign to a point are arbitrary. And here is a simple illustration of why, if you have two birds flying in these two directions, 15 degrees and 345 degrees, that's my zero in this case, mathematical measurements, 15 degrees, and you take the average of these two x bar in the standard sense, add them up and divide by 2, you end up there. That can't be the average of these two numbers for sure. So arithmetic mean, the x bar is absolutely not the measure. If x bar is no good, none of the usual measures like the sample mean, sample variance, the moments, moment generating function, you all know some of those statistics terms, moment generating function, the t-tests, f-tests are all inappropriate for directional data because they're all highly dependent on how one assigns the values to the given set of directions. In fact, this is something interesting. I got started in this field somewhere around 1960s. I should say proudly that I'm the first one to have delved into this area of directional statistics in the 60s. And then a lot of other Indian statisticians got involved. And this is a developing field at this point, although I would say 50 years old. But anyway, so what happens is all these tests people were using even in respectable journals like the Journal of Geology. There was people doing analysis of variance, which is based on the F test. That's completely wrong when you have directions or the angular measurements. And just I showed you X bar itself doesn't work. So all these measures like X bar, S square, models, what am I referring to as models? For example, there's a population model where you put a normal distribution model or some other distributions. And then sampling distributions, inference, parametric, non-parametric, everything has to be reinvented. When you're dealing with directional data, like angles, for example, you cannot use the standard measures, and you have to do something quite different than the sample mean, sample variance, and the standard distributions. So there's a whole clean slate in some sense. And I said here, my aim is not to give a complete tutorial on how to do this, but just to bring awareness to this issue. Namely, when one measures directions, one needs to think differently. Okay, here is the simple idea here. Remember, if you have two angles, alpha 1 and an alpha 2, alpha 1 is this angle. If you measure this as a number, it is that, but this is the vector that represents the angle first direction. That is the vector representing the second direction. What I want you to do is treat the angular data as unit vectors pointing in the specific directions and obtain the resultant vector of such vectors. That is the resultant vector. Well, you all know what to do this. You know, we look at the cos theta, sin theta components for this and cosine and sine components for this, add them up and you get a resultant vector. And resultant vector is this R here. So it turns out this resultant vector will be of certain length and follow a certain direction. And those are the crucial ideas right here. If you have angular data, two angles like so, think of them as unit vectors, consider the resultant vector, and look at the direction the resultant vector is pointing to. That direction of the resultant vector is a good sense of average for these two angles. So, and then more than that, I'm already reading my next slide, but anyway, we'll add the picture, it might be good to look at it. And then also the length of the resultant vector. Think of that. That length can be, if these two are length 1 each, the length can be as big as 2 if the vectors were overlapping on each other. On the other hand, this can be as small as 0. When would the resultant vector be of length 0? If alpha 1 were in the opposite direction to alpha 2. So the length of the resultant vector is an important criterion, as is the direction of the resultant vector. That's what I say here. This circular mean is defined as the direction that the resultant vector points to. It depends only on the data and is immune to what we call the zero or the sense of rotation, and has all the properties that wants in a location measure. So in addition, the length of the resultant vector, if you have n such vectors, the length can be anywhere from 0 to n, serves as a measure of concentration of the data. Longer the R is, the more concentrated the data is, meaning they're closer together, right? As we saw, if the two angles overlap in each other, the length will be 2. So the length can be as big as n, length of the resultant vector. So we got already 2 replacements for the mean and variance. What are those? The direction of the resultant vector and the length of the resultant vector. Length of the resultant vector, let's not say it's exactly the sample variance, it's a measure of concentration. Larger the R, larger the more concentrated the data is. Okay, so that's the tutorial, more or less. That is the new set of directional measurements that one needs to use. Okay, now I'll get back to the scientific questions and how they relate to directional data. Geologists actually measure the direction of flow of a river from sedimentary rocks whose age they can determine, by, there's radiocarbon dating and all kinds of measures for finding out how old a rock is, sedimentary rock is, and what direction is the river flowing. If you look at the river bed, then they can tell you which direction was the river flowing at that time. And also they can tell you, how old the rock is. This is called paleo current analysis. Paleo is past, paleo current analysis. Dr. C.R. Rao was, got me into this field. Did I already mention? C.R. Rao sent a geologist to me with this question. And the Supriya Sengupta asks me, I have collected this data on river flow in Godavari Valley. And then Dr. C.R. Rao said, oh, you know what? J.S. Rao, I was J.S. Rao at that time, still I am. And okay, he said, I should go visit this site personally to see how they are collecting data, what kind of data they are doing, how, and then I wrote several papers on these topics. How many data points should they collect? How large a sample should they do? And things like that. So early scientists who work in ornithology, bird scientists, record the direction of flight of birds to see where they are heading. This is a big field. There are books written on bird migrations. Bird migrations, as you might know, birds fly all the way from Canadian geese, fly thousands of miles, head back to their home after a certain period of time. So the people are still wondering how the birds do it. We get lost if we drop somewhere in the middle of Visakhapatnam. We don't know how to get back, but without a GPS or without one of those gadgets. So on the other hand, birds do it, and this subject is called ornithology. So it's all a matter of directions again. Directions in paleocurrent analysis, geologists, bird scientists looking at the monarch butterflies. These are, I'm not going to get into great detail, but these are all actual research papers. On each of these topics, there are dozens and dozens of papers. Some of them I wrote myself, with collaborating with geologists and biologists and so on. Okay, magnetic pole reversal and continental drift. This time it's three-dimensional directions that we are dealing with. And the direction of the Earth's magnetic field. Earth's north-south magnetic pole is completely reversed once in a while. Not overnight as you're sleeping, but over a period of 1,000 years. It takes place once every 450,000 years. On the average, north-south pole reversal takes place on the average about 450,000 years. How does one know this? Well, this again is similar kind of story. There is Earth's magnetic pole is recorded for us in the so-called igneous rocks, which are rich in iron. When the lava flows, then it settles down under the influence of the Earth's magnetic pole at that time. And so it preserves the Earth's magnetic pole. And then they can tell from this rock, how old is this rock? So I worked with a geologist and who wrote a long paper about Earth's, different types of rocks, different ages, and what was the north-south pole at that time and at this time and so on. So I'm saying here, we may be due for one since the last pole reversal took place 780,000 years ago. In fact, if you read the paper carefully, there are some rumblings of this kind. The Russia, where the North Pole used to be, is already moving apparently slowly. So this saying North magnetic pole reversal is a fact, and this happens. This again, we are saying three-dimensional directions, right? Matching the paleomagnetic directions in different continents provides further evidence of continental drift. Australia and India used to be in the same plate called Gondwana land or some such at one time. And how does one compare? We can look at paleobotany, meaning plants and so on in different continents. But you can also look at the paleomagnetic directions of rocks accounting for the drift. So you can compare them, and this is a further evidence of continental drift. So these are all, again, examples of directions. I'm just setting the stage for you to get interested in this field, in the sense there's a whole bunch of different fields where directions are measured. Directions happen to be very crucial in solving these scientific questions. Any periodic phenomenon with a known period, like a day, a month, a year, can be represented in the circumference of a circle. Circumference of a circle is, you can think of that the circle as 24-hour cycle, and diurnal variations, time of heart attacks, time for taking a medicine. This is important topic, chronotherapy, chronobiology. Timing a surgery for a breast cancer patients. You know, you may not have heard these words, but there's books written on this topic of chronobiology, chronotherapy. In other words, they say whether or not you take a medicine is one aspect, but when you take it is another important aspect. Should you take your heart attack medicine in the morning or in the evening? So this is called chronotherapy, chronobiology. And birth-death cycle, that is the topic I mentioned, where people might postpone their death beyond their day of, birthday. And so there are the birth-death cycles, you can put them in terms of directions. So this is, again, first significant digital phenomenon and cheating on taxes. Okay, what is the title here is first significant digit phenomenon. Here is something interesting. I'm bringing you a lot of tidbits, but these are all connected by the same link, namely directions. What is this about? When one looks at data that has a large variation, small numbers mixed with large and very large numbers, and pays attention to the first significant digit. What is the first thing? If it is a 0, ignore it. But only the non-zero first digit is the first significant digit. Like, for example, it can be 1, 2, or 9. How frequent are these numbers? One would expect there is something called normal numbers in, number theory. Normal numbers are those that occur with equally frequently. But this is, I'm looking at a particular kind of first significant digits, and it can be shown using circular distributions that the relative frequency of these numbers is quite non-uniform. 1 occurs nearly 6 or 7 times more frequently than 9. See this. 1 has a first significant digit, occurs nearly 6 or 7 times more often than 9. And the chance of seeing the first 3 numbers is almost 60%. This is called the Benford's law. Benford is an interesting character. He has looked at a lot of Reader's Digest magazines that they accumulated and looked at every number that came in there. And he made a frequency table of these first significant digits. Anytime, maybe it's a population of Greece, maybe it's some other number about the, whatever numbers he saw, every page, every number he categorized. What's the first significant digit? And then he found out this unusual fact that these are not equally frequent. And these frequencies are quite different. And Benford is called a Benford's law, and there's a lot of mathematics behind it now, ergodic theory and things like that to prove these theorems. I don't know how I'm doing on time, but I will try to watch myself a bit. Okay, now this is something apparently when people submit their taxes and so on, individual or a country, I'm told the Internal Revenue Service in USA, when you submit taxes, they look at your numbers and they apply Benford's law to see if you are making up numbers or if you are cooking the books and things like that. Anyway, I mentioned Greece as an example of when entering the Eurozone they gave. Okay, here is, I think we'll skip this. This is a short proof. First significant digit is xk with probability log k plus 1 over k. K going from 1 through 9. That is the probability distribution. See, if k is a 1, this is log 2. This is to the base 10. So this is the probability distribution of the first thing. This goes to something called Poincaré's theorem and things like that. But this has something to do with circular distributions. I just threw it in here, but I don't think you need to pay attention. Some more detailed proof is in someplace else I'll refer to later on. And the plagiarism and latent semantic analysis. Now, this is one of those standard, big standard topics, and a lot of papers are written on this topic. You discover a new poem or new essay by someone, you ask yourself, is this written by Shakespeare? And things like this. How do you check some things like that? This is what is called a latent semantic analysis, text analysis. This is, I'm sure if you ask some of your computer science colleagues, they'll tell you this is a big topic, namely any two texts become two different points on the surface of a hypersphere. And one can look at how far these points are to judge the similarity of these texts. So what we do here is we look at the frequency of words and then unitize that such a vector and plot that as a point on the surface of a hypersphere. And then look at how, essay written by me, essay written by someone else become two different points. And we ask ourselves, how close are these? And one can do testing whether they are copies of each other. Of course, they take the cosine of the angle between the directions, and there are papers written on this topic. One of my students did a thesis on this topic of comparing texts and so on. Okay, now here is something else. When measures directions, say the flight of birds, and comes to a statistician to figure out what their average direction is, this is typical of people come with a set of directions. Say maybe think of them as points on the circumference of a circle. And they come to us and say, what's the mean direction? What's the, this sample, the mean and sample variance? We talked about the direction of the resultant vector, the length of the resultant vector. But before you do all this is something that you don't do on the real line. We should ask ourselves the following question. Is there really a preferred direction to these birds? Or are they merely flying in all possible directions? This is called isotropy. If they are going to, if we release birds and they go in 5 different directions, all equally, all around the circumference of the circle, then there's perhaps the resultant vector is length 0. And then you don't have a mean direction. So this is called isotropy. This is a very important point in directional data. First question you ask is, are the directions, do they have a preferred direction? Or are they probably, for instance, when we see mosquitoes buzzing around, not sure if they have any preferred direction. Or when particles, like in Big Bang collide and bounce off in all possible directions. S. Chandrasekhar has a paper on this topic of, Big Bang and directional flight of these possible directions after collisions and so on. Big question is whether there's any consistent pattern to the observed directions. Now, I'm going to take a look at this topic because I think I'll at least leave you with some ideas to think about. So this is one of the first questions that comes up, namely, given a set of directions. Now, I bring up an interesting topic which is related. It's called a random walk problem. Okay, I use interesting terminology. A fully drunk starts at a bar, O, heads off in a random direction, walks L1 units of length, then falters and heads in an arbitrary new direction. So let me draw a picture for you. Here is the place where he or she starts, walks a certain length, and then he changes direction completely, a random direction at this point. Okay, that's the angle θ1. He or she walks the different direction, L2 and L. So these are and then after n steps of such lengths, he arrives at the point F. O origin, F final. So this you can show, this is the length of the resultant of these vectors. I didn't put it in that fashion because I wanted to show you the random walk issue. Random walk is R is the distance between the origin and the final point. If such a random walk ends up at the point F, after these n stretches, how far is he or she from the starting point? What can we say about R, the distribution of R? Now, you know what? There's a very interesting history behind it, which I'll share with you. Sir Ronald Ross, he won a Nobel Prize in medicine for his work in malaria vector. he wanted to know how far the mosquitoes would travel from the breeding ground and how far their density would, how the density would decrease as the distance from breeding ground increases. You see more mosquitoes around the pool than much later. Ronald Ross, there is a Ross Museum in Hyderabad. I don't know if anybody ever notices it. I went to personally visit it. Ronald Ross lived in India and he worked in India. Some people claim he lived in Calcutta for part of the time, but there's a museum in Hyderabad, Ronald Ross Museum, and he is a Britisher, of course, but British were all over India in those days. So he was in India and he won a Nobel Prize, and he is the one who connected mosquitoes to malaria. And then he said, mosquitoes seem to buzz off on all random directions, analogous to drunks leaving the bar. Two-dimensional projection of their flying paths provide reasonably good approximation. And then he asked this question to Carl Pearson. Pearson goes back way before Fisher, way before all of us in statistics. And Carl Pearson was the chief preeminent statistician of that time. So Ronald Ross asked this question to Carl Pearson. Pearson tried his hand at it for a while and posed this problem in Nature. It became to be known as the Pearson's random walk problem. Even though I joke that he neither came up with the question nor the answer. Question came from Ronald Ross and he just posed this as a question. So what is the Pearson's random walk problem? Is about this. Start at some point, the lengths are given, even that can be random. I generalize these kind of ideas. So there's a random twist, and then there's if you have n such vectors of lengths L1, L2, Ln, with random angles in between, how far would the resultant vector be? And in chemistry, this is related to length of the polymer chains. In physics, there is a interesting question. Are two violins twice as loud as one? Sound waves can be represented as vectors with amplitude and phase. And their phase difference determines if they reinforce or weaken each other, right? We all know noise canceling headphones. So this is, this is an interesting question. This is, we have a popular, a classical book in probability by William Feller, and he asks this question. Are two violins twice as loud as one? It's a superimposition of sound waves. And so these questions are related to the question I posed about resultant vectors. The answers, especially the exact ones, are not as elegant as the problem itself. And I refer to a book we wrote, a section, but this is the answer to the distribution of the length of the resultant. The length of the resultant, small r, a typical value can be 0. What am I talking about? The length of the resultant of n such vectors. And it can be as big as summation of Li, because if the guy was not really drunk, he kept walking and walking straight, he would go as far as summation of Li, because he's not taking a random twist. And then this is these are Bessel functions, J0, and so one can figure out how far the mosquitoes will be. So here is a table I give you, and the table says 95th percentile of R. What is a 95th percentile? If you have 20, suppose you have 100 steps, okay, of unit length. 100 steps of unit length, 1 foot each, let's say. If they are flying in a random directions, then 95% of the mosquitoes will be within 17 feet of where they started. So 100 steps, the mosquitoes can only go as far as 17 feet. They could go as far as 100 feet if they were determined to go in the same direction. But the 95% of the mosquitoes would stay below the 17 feet. So that's interesting. The expected length for 100 steps is only 9. Expected length of the resultant. And the probability R exceeds 17 is 0.05. That's what we call it, a 95th percentile. 95% of the things are below 17. Only 5% are above 17. So this comes out of that formula that we have here. and they can be figured out. Well, I have a joke here. A statistical test for drunk driving. In California, if you get stopped for drunk driving, they say walk a few feet and see if they walk straight or if they falter too much. And so I say if you walk more than 17 feet, you are probably not drunk too much. Anyways, okay. Here is the other thing that I mentioned to you, glaucoma study. We are actually collecting data from the L.V. Prasad Eye Institute in Hyderabad. Many of you must have heard of it. It's a very famous institute, L.V. Prasad Eye Institute in Hyderabad. They collected this so-called OCT data, the optical coherence tomography data for many patients that walk in, both for normal eyes and for those with glaucoma. Data consists of close to 5,000 circular curves on NRR thickness, neuroretinal rim thickness, and so on. So besides various covariates like gender, age. So when a patient comes in, male, female, age, what other medical conditions they might have, and they take a OCT data on such people. And the question is, based on these 5,000 circular curves, can we connect them to their gender, for example? Can we cluster them according to their age, maybe? Can we then connect it to those with glaucoma, those don't have glaucoma? And maybe there is some evidence in these curves about occurrence or non-occurrence of glaucoma. So that is the whole idea. So what does the typical ophthalmologist do? If you go to your doctor tomorrow and ask him about glaucoma, he will put some eye drop and take the intraocular pressure. It's just the pressure of the eye. It's just one measurement, and it's a very gross measure of glaucoma. But we are saying maybe there's more to it. Maybe one can measure these more intricate measurements, the OCT data, and try to get. So we do what is called functional clustering in a couple of ways. Functional clustering is clustering the functions. Let me throw you maybe, okay, let me go through this. By fitting a Fourier series of an appropriate degree and using the coefficients. So we take each curve and fit an appropriate Fourier series of certain degree and look at the coefficients and cluster the coefficients. Functional clustering is an interesting topic, clustering functions. In my case, they're curves around a circle, and are treating each curve as a mixture of von Mises distributions and looking at the parameter set for each curve. This I didn't get to tell you about it, but there is a famous distribution, like the normal distribution is so important for the regular real line. The von Mises distribution is as important for the circles. And that is what sometimes is called a circular normal distribution. A circular normal distribution is, the von Mises distribution is so much like a normal distribution in terms of its properties and so on, but of course it's on a circle. It's a distribution on the circumference of a circle, but it's called a circular normal distribution. And we say, can we fit each curve to a mixture of von Mises distributions and cluster these things? Here is, just to give an idea of what the jumble looks like, the RNFL thickness, the retinal neurofiber layer thickness, that's a curve around the eyeball. Each curve is a different color. You're not going to make sense out of this. But the point is, look at these 5,000 curves. Can you put them apart in terms of people with glaucoma? People don't have glaucoma. The gender is, can we perhaps predict based on these various, covariates, whether someone might have glaucoma, what the chances are? So I'm saying this is again a matter of direction. So directions come in 2 dimensions, 3 dimensions. In the text analysis is multi-dimensions. Oh, you know what? I'll skip this part. This is, you have noticed my name, Rao Jammalamadaka. I was known as Jammalamadaka Srinivas Rao, as all Andhras write their family name in the beginning, or J.S. Rao. In fact, there is a test called Rao's spacings test, and I was a Rao. And so, any case, so people often ask me, how did you switch from J.S. Rao to S. Rao, Srinivasa Rao Jammalamadaka? And then, you know what? One of my followers in circular data problems, he suggested to me a circular explanation. If you start with the true north, it becomes Jammalamadaka Srinivasa Rao. If you start with the true east, it becomes Srinivasa Rao Jammalamadaka. So it's like a matter of circles. Even this is a matter of circles, I'm saying. Okay, that's nearly the end of my talk. And here are some references to this is a book I wrote with Ashish Sengupta, who is a professor at ISI Calcutta. He may have been emeritus now, but and then Madia and Jup is another book. And here is a paper that just appeared. I'll be happy to share this paper with any of you. I'll post it, give it to Sridhar, and it's actually based on this talk. I gave a talk similar to this in the Indian Academy of Sciences in November, and they already produced a paper based on this talk. And so that is the reference to that. Proceedings of the Indian Academy of Sciences, Math Science Division 2020, that is this year in July issue. This is a special issue in honor of C.R. Rao, and in our package called CircStats for doing much of this type of statistical analysis and inference we developed at UCSB is available. You know, perhaps most of you know CRAN and R packages. There's a package called CircStats that does this resultant vectors and some of the tests for isotropy and things like this. So that package is developed by my students and me, and that is available. Okay, I think I'll take a break now, and I am going to, I don't know if you have any procedure for asking questions or things like that, but I'll give the stage to Kameshwari again now. Hello, who is going to take over from me?
Thank you very much, sir.
Okay.
It's an honor to all of us and giving us your valuable time and sharing your knowledge. So before question and answers, I now request our Honorable Vice Chancellor Sivaramakrishna Garu to kindly share his message.
Hello, am I audible?
Yes, sir.
Yes.
Am I audible?
Yes, sir.
Yeah, I'm sorry. In the beginning, I would have joined with all of you to give maybe a small welcome to all of you, but because of technical issue, I could not. And no regrets. Now I'm totally, what can I say? I'm not getting the words after listening to Dr. S. Rao Jammalamadaka. And first of all, a warm and hearty welcome once again to all the panelists and also the participants to GITAM University. And I need not elaborate about GITAM, all of you may be aware. As a Vice Chancellor, let me take a few minutes. It's a 40 years old institute. As a university, it's a 13 years old university. And we are now having about 23,000 students in all the three campuses put together, pursuing 200 programs and also MPhil and PhD. And GITAM is now having almost all the disciplines except agriculture. That's one uniqueness of a private university, particularly in this part of the world, having all the disciplines, and it has grown strength by strength from last 40 years, starting from engineering, management, sciences, and other programs. Now we have a medical sciences, dental, and general medicine. And first of all, let me congratulate the Dean and his team, Dean of Science, Professor A. Subramaniam and his team of principals and HODs of mathematics of all the 3 campuses, and the faculty, particularly who has initiated this concept of International Faculty Development Program on recent advances in mathematics and statistics. It's a very, very interesting and very, very important in the present day context. After listening Dr. S. Rao Jammalamadaka, now the people of mathematics should feel proud, statistics and mathematics should feel proud of your profession, and you are there in everywhere. Earlier we used to feel that, okay, mathematics means so they will teach some numbers and people will learn and then move on to their professions. But I myself, as a management professional, management academician, even though we use mathematics and statistics, but after listening to Dr. S. Rao Jammalamadaka, I'm feeling totally different. Thank you so much. You richly deserve to be a student of C.R. Rao. And we are very fortunate that C.R. Rao Garu has visited our campus in one of the occasions. And that time itself, our late Dr. M.V.S. Muthu Garu was very much impressed and requested him to associate and come frequently to the GITAM. And on his birth centenary, our people have taken initiative, and it's very, very interesting, and I really congratulate the total mathematics and statistics faculty team for taking this initiative and also inviting the right person. I think maybe Dr. S. Rao Jammalamadaka has accepted by seeing that Professor C.R. Rao's birth centenary. On that occasion, that event is taking place. That's how he associated with this. And it's a good beginning. And I'm really, really, really happy the way you have explained and this matter of direction. Even though I'm not well-versed in mathematics and statistics, as a common man, I can understand how important it is. And the way you have presented, even though there are scientific and technical issues are there and formulas are there, I can relate and grasp how important it is. That is the greatness of a presenter, to make an ordinary man to understand how important it is. It's not that just giving some formulas and making some presentation. A wise man always bring the things to the common man. That's what, as an academician, as people growing in their respective fields, even though it's very complicated, at one point of time, they bring to the level of a common man how it is going to impact all of us. And I see the topic, it is going to impact almost all walks of life of a human being, maybe the nature I can understand, I can say the universe. So the scope is very wide, the way he has presented. And I think all the people, those who have participated, can take a lot of leads out of maybe a presentation of 45 minutes or 1 hour, but it has given you scope to do research in your lifetime. That's what we can see, the way he has given a direction for the future mathematicians and statisticians, and you have a lot of scope to do the things. After seeing this, I think people should understand the interdisciplinary approach, how it will be helpful to the humanity, how it will bring the unknown things to the known. The researcher job is that all these things are there, but how to bring it in a way to known to the common man and in a way to use it for the betterment of the society or betterment of the human life. That's one part of it. And the way he has presented, very, very interesting, and I think maybe first time I'm seeing a pure mathematician or statistician giving a talk in a way to acceptable or otherwise in a way to understand to the common man. And I thank you, sir. And it's not just a welcome for this webinar. We wholeheartedly welcome you to the GITAM physically. You have to visit our GITAM and suggest and bless the departments of mathematics and statistics of the GITAM University in all the 3 campuses. And we create an opportunity to invite you to the GITAM and see that you visit GITAM and bless the GITAM, and C.R. Rao's presence in Andhra University and your presence also has to be there in GITAM. With that, definitely we will take it forward, this mathematics and statistics as an important subjects in GITAM University. We are also working it out to take it forward, the advanced aspects of mathematics and statistical aspects. And with this, I once again thank all of you for giving me an opportunity to listen to a great person. Dr. S. Rao Jammalamadaka is a very lucid way he has given a presentation. Sir, I have one idea. Similar way, can we use this matter of direction for behavioral directions? The behavior pattern of people in a different parts of the world or different places or in one's life, the behavioral directions, can we bring into a particular pattern? It's just only out of your talk, it has come to my mind. So how to bring a behavioral direction patterns to know about the people or to know about the culture, to know about, I think there may be some research work is going on, I don't know, but after listening your talk, I thought that these behavioral directions also can be taken as a part of this type of research. And I'm happy to inform you that L.V. Prasad Eye Institute Managing Director Guntupalli Nageswara Garu, we have given, we are happy and we are honored to give him a doctorate in the last convocation, and he's going to join with us as one of the governing body members in near future, and that way we closely associate with L.V. Prasad Eye Institute. With this, I once again thank you and thank all the organizers for giving me this great opportunity. Thank you, one and all.
Thank you, sir. Thank you very much for your kind words. Yes, I'm sure there's scope for involving directional data into behavioral aspects, but I have yet to think about it. Thanks for raising that question. Thanks again.
Thank you, sir, for granting your precious time in spite of your hectic schedules and sharing a valuable information. Now, with this, we start the question and answer session. So, questions?
Good evening, sir.
Good evening.
Sir, this is Dr. Sridhar Akiri, sir.
Okay, hi, Sridhar. You have been
Sir.
working hard. It's a good success so far.
Thank you, sir. Thank you very much, sir. And this is a part of time for question and answer, sir. And we are very happy. The question and answer section started with our beloved Honorable Vice Chancellor, Professor Shivaram Krishna Garu. And due to some time restrictions, we will ask only 2-3 questions, sir.
Okay.
The first query from the participant is, what will happen if we use usual probability distribution for modeling circular data, sir?
Oh, well, you know, clearly, as I already said, you cannot use this sample normal distribution, because normal distribution is, for example, for the whole rail line, -infinity to infinity. circle goes round and round. There's no beginning, there's no end. So the modeling is different. The usual techniques like the sample mean, sample variance, as I demonstrated, are wrong. So you can, if you rule out X bar and S square, 90, well, I'll say 80% of regular statistics is out the window.
Thank you, sir. Sir, what are the software required to analyze these type of data, sir?
I think the R package that's available is just any, these days everyone can download and start pushing buttons to with your own data set. There's no requirements.
Okay, sir. Okay. Sir, another participant, Professor Chandrasekhar Garu. Sir, can we connect graph theory random walk to the present talk random walk, sir?
I think not quite, because in the graph theory, what you have is a particularly a lattice structure. You go a certain length in a x-axis, x direction or y direction. But here, this random walk is really random in the sense you walk a certain distance and you turn around, twist around and walk another distance. So this random walk is truly a random walk on the plane. You're like mosquitoes buzzing around and so on. So it's not quite related to the random walks that we talk about on the lattice.
Thank you, sir. Thank you very much, sir. So, dear participants, what I can say, fantabulous, informative, enlightening session on a matter of direction by Professor S. Rao Jammalamadaka. At the outset, I thank the management of GITAM, our beloved President, Sri M. Sri Bharat Garu, our Honorable Vice Chancellor, Professor K. Shivaram Krishna Garu, staff, together with the delegates of the webinar. And on my personal behalf, we are profusely indebted to the distinguished Professor J.S. Rao of California University and accepting our invitation, who delivered a scintillating inaugural address on the present day issue on the advanced technology, core and novel specialization, a matter of direction. His profound knowledge exhibited the future specialization in statistical modeling aspect in dealing with the measurement of direction, focusing on earth and biological applications, which is a needy of the present day, and his skills were portrayed in the presentation. The video clippings and ads motivated all the delegates presented in the inaugural session. Sir, we are extend our heartfelt gratitude to you from core depths of our hearts. Thank you for your sparing your valuable time in sharing your thoughts on the Nobel of Specialization. Once again, thank you, sir. Dear participants, kindly fill the feedback form. Already we kept feedback form in the chat box. Sir, thank you, sir. Thank you very much, sir.
Thank you.
Thank you very much, sir, for joining us in this evening today, sir, to all of you.
Professor Uma Shankar Garu, thank you very much.
Hi, Uma Shankar. And K.S. Rao, I think, has left apparently, but K. Srinivas Rao. I see a lot of familiar faces. I'm almost sure I know some of your faculty and the computer science group. And
Yes, sir.
well, it's a wonderful campus, and I'm happy to see it's growing from one campus that I knew in 2005 to 3 campuses now.
Yes, sir.
Great, great.
Thank you, sir.
Can I take leave now?
Yes, sir. With pleasure, sir.
Okay, thank you. Bye now.
Yes, thanks.
Thank you, sir.
Thank you, Vanita. Thank you, Principal, sir.
Thank you all.
Thank you, HOD sir.
Thank you, Sridhar and Kameshwari madam, Trisha madam, and Ramesh, and all of you. Okay, Sridhar and everyone, and Sridhar and all members. Thank you, sir. Can leave now.
Thank you, sir. Thank you, sir.
Hello.
Thank you, sir.
శ్రీధర్ గారు మీ సార్ మ్యూట్ లో ఉన్నారు సార్. హలో
సార్,
మీ సార్ మ్యూట్ లో ఉన్నారు సార్. ప్రొఫెసర్ ఉమాశంకర్ గారు మ్యూట్ లో ఉన్నారు.
హలో.
సార్ వినిపిస్తుంది సార్. నమస్తే సార్.
Right. Okay. So how are you? How is life? How are the things are going on at the university?
Fine.
Uh,
Fine, sir.
Good.